In this problem, we're given a couple states. One state is when both Frankie and Johnny are alive. Another state is when one of them is alive and the other one is dead. And the other state is when they're both dead. So we want to find the derivative of the reserve at state 0 at time 10. So in order to do this, well, first we want to draw out the scenarios. We know at state 0 they're both alive. State 1, Frankie is alive and Johnny is dead. So I'm getting it from these bullet points over here. State 2 represents the time that Johnny is alive and Frankie is dead. And then obviously there's state 3 when they're both dead. And obviously you cannot move from state 1 and 2 to 3. Or like once you're dead basically. So there's no mobility there. So we can only transition from state 0. And the other thing we should note about this problem is that we get paid if exactly 1 is alive. So 8,000 per year continuously while exactly 1 is alive, or 10,000 when they're both alive. So you get no money if they're both dead. So really, we should not be considering state 3. So this one is really not necessary for this problem. So in order to solve this, we need to use Field's differential equation. And here we're looking for when I is equal to 0. Okay, so we'll be plugging it in, and let's see. So this is the value while we're in state 0. That's how much we're going to get paid, which is the 10,000. And these are the transition forces. So notice we only go up to 2 because we're going up to state 2. State 3 you don't get paid, so we're only going to consider states 1 and 2. And then it's just a matter of plugging it in and getting an answer of negative 4,224.644 as a final answer.